We're still looking for somebody to take notes.
If anybody does their meetings like me, they wait for the Outlook notification to come up and only then they connect. So it might be, so I'd include a few minutes at the beginning of the meeting for people to connect.
Well, we're up to 31 participants here, so we're going pretty quick. I haven't looked to see how many people total are registered for IETF this time around. I know there was some fussing last time or time before about Meet Echo, but I tell you what, when Meet Echo works, I really think it's a wonderful tool, and I
think it's great.
People did.
Yeah. Thanks, Robin, for volunteering to be Jabber Scribe. Yeah, so we're still looking for a minutes taker, though. Today's meeting is shorter than usual, so it should be an easier job than usual. Any volunteers for minute taking? Well, we'll ask again at some point, but.
Yeah, it's about time to start. Give people about 1 or 2 more minutes to come in.
Yeah, so since time is starting, let's slowly go through the note well. It's on your screens, and once we get to the agenda, we'll start the meeting properly. So the important part on this slide is the IPR disclosure rules. Everything and these meetings can be made public, and that we will all be respectful. And another key point is the IETF is not standards development, unlike the IETF. We can publish IFCs, but more important, our role is to encourage collaborations rather than think about standards. And I believe that's what we've been doing quite well so far. So let's keep doing that. Right. So to start the meeting proper, we do need a minutes taker. So that is a brief pause. Now that we have 55 participants, does anybody want to volunteer to take minutes?
Before I behave like a professor and actually appoint someone.
There's a volunteer who says, Darren, who says he is not familiar with the status of the draft, so if there's a better attendee, then. So we'll give it a minute, and if nobody steps up.
Well, I think Darren is an excellent choice. It's a good opportunity for Darren to get involved in the day-to-day work of QIRG. Thank you for volunteering, Darren.
Let's give it a few more seconds.
Like Wojtek said, I don't think the note taker's job is going to be terribly onerous today, in terms of the total amount of work that has to be done. Capture the key points of the Q&A and what gets promised, or work items that get handed out in terms of the 2 drafts that have to be that are the primary point of discussion. And then grab any key questions or comments out of the open discussion section, and that's about it.
Yeah. Yeah, and somebody just shared a link, and I think we'll leave the minute taking then to Darren and Sean on the relevant link, and then I guess we can then start.
All right, Sean and Darren are.
Just a reminder, the blue. The blue sheets are now taken automatically through Meet Echo. So just FYI, there's no blue sheets to fill out. Okay, so let's start proper. Welcome everybody to the QIRG meeting for the IETF 110 online. It's nice. It's like a decade because the proposal for QRG was at the actually it was IETF 101, not the 100. So it's not a decade, 10 IETF meetings yet. Okay. What's the agenda for today? 5 minutes just to get things sorted. Then we have 2 drafts which we're going to go update through. I believe there's been quite a few significant changes for the use case draft, so I'm looking quite forward to hearing from Chonggang on those. There were not as many updates for the principles draft, and hopefully we're nearing the end for both. And we're also going to have a discussion group around a paper that Rodney posted on the mailing list about a development roadmap for quantum interconnects. So if somebody feels lost during the draft discussion, it might be a good chance to catch up at least on the paper to participate in the discussion group. And then a bit of an open floor. We've got a few discussion points, at least I have one I want to suggest. The current document status is that there's 2 active drafts. They're slowly converging. And there's 3 expired drafts, which I include because every now and then somebody asks about them. And, well, if somebody wants to, they can pick it up or do something more interesting with them. Now, I want to make one announcement. So one thing that Rod and I agreed at some point is that we'd also like to emphasize the educational and aspect of the QIRG. And for that reason, we will be running some QIRG seminars where we invite a speaker to give a talk and open the floor later to questions. We'll be organizing that between the actual IETF face-to-face meetings to kind of allow us to really just focus on that one seminar. And the first one is happening actually in 2 weeks' time, exactly 2 weeks' time. The speaker will be Mehdi Namazi, who is the Chief Science Officer of QNECT. QNECT is a startup out of Stony Brook University working on quantum repeaters. So especially they're looking into miniaturization, and they have been thinking about various aspects, including merging with existing infrastructure. So if that's something I believe that will be interesting to everybody in the QRG. So the announcement has been posted on the mailing list, and it's also registered as a virtual intern, so it's on the data tracker. We plan to have roughly 1 every 2 months or so. So if you have suggestions for a speaker, or you yourself believe you have something you would like to share with the QRG in a longer seminar, do contact me and Rod for that purpose. I think that's it for minutes. So the first agenda point was we'll hand over to Rod. Yes, sorry.
One thing. So while you were running through this intro stuff, Kiriti joined the queue briefly. I'm not sure if they want to say something. I have a meta comment at this point. Yeah, go ahead. Let's see. How do I enable you?
I'm enabled, I think.
Okay.
Can you hear me?
Yes.
So, yeah, one of the expired drafts, the one on QIRG Advent, I think we called it, is possibly going to come alive in the next few months. I've just joined the Marquee, the Mid-Atlantic Research Quantum Internet, or something like that, as an advisor. And if they feel that that's something interesting, I would revive the draft.
Sounds great.
Great. Looking forward to it.
Yeah, great. Thank you.
Okay,
thank
in that case, let's hand over to Chonggang to give us the update on the internet use cases. Let me stop sharing my screen, and I'll grant screen too.
Hello, hi Boja. Can you see my screen?
I can see your screen. I can hear you.
Okay, thank you. Should I start?
Yes, go ahead.
Okay, thank you. Yeah, good morning or good afternoon, depends where you are. So this document is about the applications and the use cases for the quantum internet version 04. So first, we'd like to give you a quick recap on the previous versions of this document. So the version 0, it was uploaded as a research group document back in last May. And then after that, version 01 was presented in IETF 108. And then based on the comments, feedback from IETF 108, we generated one version 02. And then after that, version 03 presented in last IETF meeting 109, especially based on the feedback from Patrick and Wojciech. So basically, as you can see, in the past, this document has been improved a lot based on lots of good comments, feedback, and suggestions from the co-IRG team. So the latest version 04 basically trying to address the comments and feedback we received during last IETF meeting 109, and also some after meeting comments from Avero, Wojciech, and Joey. So that's kind of a quick recap. As you can see, it kind of the document kind of keep progressing. The major updates in the present version 04, as you can see here, the outline and the whole document has not been changed. So major changes, the first, we clarify the control and the data plane classification. That's changed to the section 423. And then major changes, just to the section 5 in terms of 3 use cases. So first, to the QKD, we call the secure communication setup. We added additional description about the QKD post-processing based on the comments. We also classified on the user identity and the privacy in QKD. This issue has been discussed in last meeting. So basically, we clarified QKD is kind of just to exchange a secret key, and not necessarily to disclose the user identity or violate any kind of user privacy. And then for the section 5.2, secure quantum computing with privacy preservation. So we added quite a few description about the blind quantum computing. And also, based on comments, we changed the use case diagram. Before we have the use case like the use the Amazon device, but this time we kind of make it simplified a little bit and just call the home device, could be a gateway. It wants to delegate the quantum computing from the gateway to some quantum computers in the cloud, for example. That changes to the 5.2. And then the 5.3 distributed quantum computing basically added more description, because in general, distributed quantum computing could be in 2 forms or 2 types. The first type is quantum assisted or quantum aided distributed computing, which means still it is classic computing, but we use a quantum mechanism like the entanglement to improve the classic computing. That's one type. The second type is, the quantum computers, they are distributed in different places. And then for this scenario, we call the second type. That's kind of the focus in 5.3. And then based on that, we added some clarification. Yeah, and then because of those kind of updates, we have kind of adopted a little bit more references, and some older references have been updated. Basically, quite a few new references have been added to the document. That's and then by the way, all this kind of major updates they have been posted in the mailing list. And then I got a confirmation from the people who made the comment. So for the next step, so we feel the version content of version 4 is stable now because it has addressed the discussion and comments from last meeting and also after last meeting. Basically, it has addressed all these kind of comments. So for the next step, we were wondering, and our goal is to ask the team and towards the research group last call, because we feel, as I mentioned, the comments from the preparation has been addressed, and this document has been discussed quite a few times in each past IETF meetings. But of course, at any time moment that we need to get comments and feedback from the quality team, so we can continue to improve the documents. That concludes my presentation today for this application and use case document. Happy to take any question or comments. Hello?
Thanks, Chongyang. I see Kirity's raising his hand. Do I have to unmute Kirity? Oh no, he can himself.
Hi, can you hear me?
Yes.
Okay, I had a question on distributed computing piece, end of section 5, just before section 6. When you talk about two channels, there's a quantum internet and then there's a classical internet. This is figure 4. Is the intent of the classical internet to be able to set up things that the quantum computer needs, or is this completely a side channel for any regular communication that's needed between the two end computers?
Yes, that's a good question. I guess for this figure, the goal is, like you mentioned, first goal is to to correlate this quantum computer A and quantum computer B in order to set up the system, enable, and also both computers may exchange some the computation results. That's kind of the major goal. But of course, the second goal is if there is any need between two quantum computers for classical communications, this classical internet providing the classical channels could serve that purpose as well.
Okay, so in a way, the classical channel is a control plane for the quantum computers to say, here's what I have, here's my capabilities. Because in doing the Advent draft, we were thinking of a parallel classical channel over which you exchange properties of your quantum system and maybe initiate entanglement or understand how to distill the entanglement to a better entanglement, stuff like that. So you do that over the classical channel. So figure 5, figure 4 is an instantiation of such a system, or could be used as an instantiation of such a system.
I think yes. My answer is yes. I think it could be used for that purpose. But because this document is kind of the use case application, we were trying not to touch too deep on the technology, because as you said, the entire distribution actually, as the chair's slide shows, there is a separate document talking about how to do that. But here, definitely, this classical internet could be used for that purpose. Yeah.
Okay, thanks. I see the ID van meter QIRG quantum connection setup. Maybe I have to go read that first and understand better. But thank you.
Yeah, thank you. Thank you for a good question. Yeah.
Any other questions? I have a question. So I've already raised this with you briefly when we were doing our round of feedback, but I never really finalized it. Kind of got distracted. But so in Figure 5, you have the people who have the draft open, I guess, can open to Figure 5. There's the outline of the 6 stages. And what I'm not clear about is the difference between stage 2 and stage 3 in the way you're describing it in the figure, because the example in both cases is secure communication. And then the characteristic for one of them is long-distance qubit transmission, and for one of them is entanglement distribution. Now, I understand all the words and terminology used. I'm just a bit confused what's the real distinguishing factor here between stage 2 and stage 3. Is this a strict reference to the quantum internet stages paper?
Yes, logic simple answer is yes, because that paper described the stage 2 as a prepare and then measure networks. Stage 3 is entanglement distribution networks. So correspondingly, we were trying to see here, the stage 2, the application could be just a long distance qubit transmission for the QKD without using any kind of entanglement related technologies. But stage 3, because stage 3 in that paper, they say entanglement distribution networks, which means entanglement distribution is available. And now we could use entanglement distribution based long distance QKD. That's kind of ideal, trying to map the different versions of QKD to the stages described in that article.
Yes, right. So, I think everything from stage 3 onwards is clear. So from entanglement distribution onwards, I think that's clear. But you described stage 2 as end-to-end security without relying on trusted nodes. Is that actually stage 2 as described in the paper? Because I think I'd have to reread that stages paper.
I can double check, but I think so. But I could double check.
So I'm not sure about that, because in general the trend is to go to entanglement distribution networks to basically beat the distance limit, and the ability to transmit qubits long distance without entanglement distribution network would require some form of forward error correction. Rodney knows more about that than I do, though.
Or maybe they make. Sorry.
Yeah.
I guess the major difference between stage 2 and stage 3 is with entanglement or without entanglement. Maybe I could, in stage 2, I could, revise that sentence: end-to-end security without using entanglement, instead of without relying on trusted nodes. Would that be more clear, or?
I think the issue I'm having is with the distance, not the security.
Okay.
But there is also a security implication. So I'll tell you what, like, I don't know if we have time right now to say more. I'll read into that stage 2 versus stage 3, but that's, of all the things in the draft, that's the only thing that I've picked up on lately. So otherwise, I like the changes so far. And I'll let Rodney say whatever he was going to say.
Okay.
I was just going to comment that as valuable and important as Stephanie's roadmap document is, that description of the stages, it's written in pretty terse technical terms in the science paper, and so having an interpretation of that that's more accessible to people in the IETF, IRTF community, I think that's a really valuable contribution of this draft. So I'm actually sort of tempted to ask for this to actually be, this particular section of it to actually be lengthened a little bit, because I think it's actually one of the valuable things that it contributes, to sort of bridge those two communities together.
Okay.
So Wojtek,
That's a personal comment based on the content rather than a request from the chair. I do think it's also. I think my opinion is the documents reached the stage where it's ready for a really hard critical reading from both experts and non-experts, to see that it's actually that what's written is actually correct, but also that it carries the message well to people who are non-experts. So when we're ready to say this is ready for last call, I think it means we actually do need to have the one round of pretty serious reading on it from everyone.
Kiriti was saying something.
Yeah, my naive interpretation of stage 2 and stage 3 is stage 2 is one hop and stage 3 is multi-hop, using entanglement exchange. So to your point about distance, if I can't get there in one hop, I might have to do something in the middle and then keep going. I don't know if quantum really works like that, but that's my naive reading of this.
Yes. Yeah. I'm going to admit, like, I'm in the field and I get confused about the first few stages as well sometimes. So it would be worth actually just like really clarifying those stages in this draft. It will benefit.
There's a comment from Robin in the Jabber chat. Actually, isn't stage 2 there to accommodate long distance via quantum state exchange mechanism based on bell pairs, as I recall?
That
and then
would
followed up with
be,
a describe what I'm just thinking of. Yeah.
So that would be entanglement based.
Yeah.
Distribution.
Yeah. Thanks.
Yeah. I would have to go back and look at the exact definition in the paper to say for certain, but yeah.
Right. Time's up. We can return to us in the open floor if we don't have anything to discuss in the open floor. Thanks, Chongyang. I think that the way forward is to focus on these stages and really make sure we're not. Well, basically, there's some confusion here going on, and it would be worth clarifying. But otherwise, I kind of agree that it's converging slowly.
Yeah, so the one other final comment that I wanted to make for it, and this is actually, I think, an appropriate thing to say as chair, is that now that both documents are getting close to final call on this, personally, since I've been much more involved in Wojtek's document, I have a better understanding of that. I'm actually pretty comfortable with the terminology that's in it. So one of the things we do when we read Chongyang's for final reading is to make sure that the terminology meshes well with what's in the architectural principles document.
Right.
Great. And Kiriti's volunteered to read the use case draft as a non-expert. So good. Thanks.
Awesome.
All right, we do need to move on.
Yeah, Rodney, can you chair the next section?
Yes. So the next one that's up is actually Wojtek's own draft on architectural principles for the quantum internet. And let's see, it's 57 after right now by my time, but this is the other main item on the agenda. So we said 10 to 15 minutes, but if this one runs 20, I think that's okay, Jim.
I'd be careful because we still want 15 minutes for the discussion group you want to have. So, and we only have 1 hour today.
Yeah. Well, I do want to cover that because I think people will get something out of it. But this document's at the stage where
well, I'll just get started rather than using up more time.
Yep.
I don't actually have much to update because we've been slowly converging, but I'll start with a quick recap. First version was prepared for and presented at IETF104. Motivation is to address a charter point for an architectural framework delineating network node roles, definitions, common vocabulary. First step. Important. It's a first step. It's not an architecture itself. And also, actually, it serves as a good introductory document to people without a quantum physics background. In terms of practical stuff, you can find the latest version on GitHub. I only upload a new draft version just before the IETF meetings. It's just, I find that just easier to work with. I always because GitHub also gives you diffs. To the core, what has changed? One of the main points, outstanding points, was to align. The use case draft actually uses the control plane terminology, slightly differently than I originally did. And the consensus was actually that I was going to adapt the terminology in the principles draft. Basically, originally I wrote that the control plane only manipulates classical data, but there are potentially some control plane tasks where you want the control plane to actually manipulate quantum data as well, such as a quantum ping, for example. But I did not make any concrete boundary drawings, etc. Because that's not the purpose of the document, and nobody wants to go in that direction in this document. So it's merely just opening the possibility. Rodney also has sent a bunch of feedback. It's accounted for. You raised some concerns if the document is consistent with some uncommon proposals for quantum internet, which includes quantum internet by cargo ship. And well, my stance is, which I did show in the mailing list, is that even if they're not 100% compatible, I don't think that's an issue because we're not publishing a standard. And if there's an evolution or deviation down the road from the principles, I think that's okay, and that's just the nature of research. And I mean, this is just a starting point, not the end point. And that's actually it. Are we ready? There's, as far as my current to-do list for this draft is actually just order the references, and otherwise, other than that, I'd basically say it's done and ready to go to the next step.
All right, PD, you want to step in and comment here?
Yeah, on the previous slide, when Wojtek talked about not 100% consistent, are you saying that the document is not consistent with some, or that describes some uncommon proposals? Because I would like the terminology to be consistent, but you know, if you describe.
No. So this is more like looking forward. I at the moment, I should have clarified. At the moment, I do not see anything inconsistent. I myself, and nobody has raised any inconsistencies. Rodney just mentioned that there's some uncommon proposals which somebody needs to have a closer look at. At the moment, I don't see anything inconsistent. Ultimately, even I had a look at the cargo ship, for example, one, and the quantum internet by cargo ship, I felt was basically falls under all the terminology we use in the draft. I do not feel like I'd have to add anything to make it align with the cargo ship proposal, for example. There was the other concern was about the all optical quantum repeaters, but I'm not an expert on that, so I cannot talk about that.
Yeah, we're actually doing research on the all optical ones, but there's still various aspects of actually using the all optical ones that I haven't fully wrapped my head around how much it changes the network architecture. So I can't say what we've got.
Yeah, and ultimately we don't propose a network architecture in this document. Yeah. So when I say hundreds. If somebody comes in the future and says, here's this brand new technology of a quantum repeater that we didn't fully understand today, I think that would just require new work rather than making sure we account for every possibility that's going to come our way in the future.
Yeah, I'm okay with that. As you said,
But no,
the
at the moment, I do not see compatibility, which is anything that currently exists and I am aware of.
Okay, we've got 2 questions in the chat here. If we've covered that, so if you think we're okay with that, I think I'm okay on that. So Robin's comment was if there's a reference for cargo ship, I'll get you the reference. I'm actually one of the authors on that paper. The first author is Simon DeBitt. But Joey Salazar has a question here. Where are these proposals going? Joey, do you want to comment further on that? I'm not quite sure what the question means.
I understand that this is like looking forward into potential proposals that will pop along the line. But I was just wondering, like, the proposals that you already mentioned, like the cargo ship and the cargo ship one. Like, where are those proposals going? Like, are they being brought into court here at the IETF or somewhere else?
Oh, at this point, they're pure research papers, purely at the idea level, and so if you had asked me before the Chinese satellite was before the results of the Chinese satellite experiment were announced, I would have said that I thought the first way entanglement would actually be distributed between 2 continents would have been by literally carrying error-corrected qubits from one location to another. But the Chinese satellite experiment has been so amazing that satellites are actually looking a lot better than I thought they would a few years ago.
All right, so then we're talking about potential.
Yeah.
Oh, I'm so sorry to interrupt. Then we're talking about potential proposals that might not come to QUIRC or the IETF, right?
Yeah, they're a long ways from actually even experimental demonstration, let alone ready for anything like standardization at all. The parts that are closer to needing real interoperability and real protocols that are well defined with the kind of expertise we have here. The near-term ones are really metro area networks and over a distance of maybe 100 or so kilometers, like the network that's actually being developed in the Netherlands. But as laying out an architecture or at least even architectural principles, we want something that's going to continue to work for us for as long as we possibly can.
I mean, and as has been pointed out in Jabber, there's a bit of an analogy to make to IP by avian carriers, which is that IP is so good that you can actually run it over pigeons. So the idea is that if this architectural principle is sufficiently well scoped, it could also run, maybe not over pigeons, but over cargo ship at least. But yeah.
All right, there was another question in the queue there from Alexandra Petrescu. Is quantum internet a network of quantum computers, or is it a quantum network of classical computers? So, Wojtek, you're the author. You want to answer that one?
I'd say actually, originally I'd say quantum computers, but there is a bit of a caveat to saying just quantum computers. Yes, in principle, in the future, we want to it's meant to be a connection of quantum computers with each other via quantum means, so they can exchange qubits with each other, rather than 2 quantum computers connected by a classical internet. That's the key differentiator. As we're not talking about 2 quantum computers communicating classically. We're talking about quantum computers communicating using quantum mechanics. But in terms of classical computers can be connected by quantum internet, that one could actually call it that because, for example, QKD, quantum key distribution, does not actually need a very sophisticated terminal. In fact, you can actually build quantum key distribution using just a photon emitter, which without a quantum memory. And there are startups, for example, in the UK, who are building them in a form factor of a PCI card. So something that you can actually insert into a classical device. But you obviously would need to connect it to fiber, but the point remains, it is actually a card you could potentially insert there. The startup is KETS. But if you want more details about why we only need an emitter, if you look at the recording from the previous IETF meeting, there's a talk by Josh Slater about MDI QKD where which is actually built around the idea that you only emit photons from the endpoints. So it could basically be just a PCI card you plug into your classical computer. But more sophisticated ones will require quantum computers connected by quantum entanglements to each other.
Yeah, one of the areas where
I think you have a look at it.
Sorry, go ahead. Who was that?
Yeah. This is Alexander Petersburg. Thank you for the reply. Yes, I will look at the recording that you indicated. And thank you for and that quantum internet would be both options that we discussed, both a quantum communications classical computers, but also maybe regular channel connections in quantum computers. The doubt I have why is about this network might have a particular need. Quantum before this internet, then, I don't know. Yeah. Okay. I will look at this in more detail to understand better here. Thank you for the explanation.
So the one comment I would add to that is that so the quantum internet will provide a particular service. It will provide end-to-end entanglement, and how that gets used, QKD is one of the applications. But whatever service the quantum internet is providing will get integrated into a larger information system of some sort. And the way most of us perceive that larger information system will be through some sort of classical service that's a wrapper around it at least, and even the quantum part may be just something small. But the interfaces for how the quantum services get integrated into the classical internet is one of those things where I guarantee you there is not enough work going on in the world on that topic. And that's one of the places we want to get to with QIRG, is providing the work on that particular topic. So that's why the expertise of this community matters in building these things.
Yes, and since we're almost out of time for this, it seems that most feedback is actually questions now. So does that mean we're ready for an RG last call?
My own opinion as a co-author of this is that I think the document's really pretty much ready. I would love to have Sean Turner and other people like that read it and give their feedback. People who have written a number of RFCs to see whether or not they feel like it's at the right level. Now that we feel like the technical content is there, does it have sort of the right characteristics so that it helps people in the right way? Speaking more as a co-author, I think it's working.
So what I'll do is I'll post it to the mailing list with an explicit suggestion. Please read, so that before the next meeting, before even the next meeting, we have already a question of whether it's ready for last call. So that hopefully the next meeting it's getting finalized, not.
Well, my opinion is this one is ready for us to say, here at today's meeting, it's ready for us to say, last call, you have 2 weeks or 4 weeks to read it and give comments, and then after that, we're going to push it to IRSG.
Okay, so what do we do now? Do we do some kind of consensus voting, or?
I don't think we need anything like that. I think we just need to give everybody the opportunity to make their last.
We'll post it to the mailing list then.
So we should pick a time frame, 2 weeks or 4 weeks or something, for people to give their final rounds of feedback and say, unless there's anything critical that comes up as of this date, this many weeks from now, we plan to push it to IRSG for their review. Yakov points out that there is a show of hands tool if we want to use it. That's actually a good idea. Let's see. I have not used the show of hands tool before as a chair, so let's see. How do we run that? Show of hands for people who think this is ready to go to last call. Let's see. Show of hands tool. Start session. There we go. A new virtual hands session has started. Yeah, there we go. Okay, so people can actually raise their hand if they think it's, well, Well, let's see. So Sean says the question would be who will review in the next 4 weeks. I wanted to do first. Let's do the question of do you think this is ready for us to actually push it back out and make a last call for it? My opinion is that we're ready to ask for last call on the mailing list for within the working group. There's 7 or so.
Well, I was looking for the tool.
And-
You have to click in the top right corner.
Yeah. Let's see. So far there are about 8 people, and let's see. So there's raise hand and do not raise hand, and so far we are at. Well, we briefly had somebody who was at do not raise hand, but I guess they switched to raise hand. So if you think it's not ready for internal or research group last call, click do not raise hand. If you think it is ready, click raise hand. And we've had somebody's toggling sort of back and forth there. A couple of people are. All right. Sean and Joey point out that last calls for reviews are usually 2 weeks. We've got 1 or 2 people who don't feel like it's quite ready for last call yet. All right, I'm going to end this because this is just sort of an informal level of thing anyway here at this point. Let's see. All right, so if you think it's not yet ready for a working group last call, that means it's incumbent on you to tell us why. So what is it that you think needs to be done before you're ready to send it around for a last review? So
whilst we do that, I suggest we move that to the mailing list because we're now 15 minutes left, so we won't actually have time for an open floor. So I suggest we just move to the discussion group.
So I'll say this. Let's see. We'll give people 48 hours to say on the mailing list. You know, the people who stuck their hands up. 48 hours to post what your major concerns are on the QIRG mailing list, and in 48 hours, if we haven't seen any major work that needs to be done for it, we'll issue a 2-week last call from inside of the research, the RG. Okay. Sound reasonable? All right. Let's see. So the last thing, there are a couple of comments coming in through the chat there. Let's take those either offline or to the mailing list, or continue the discussion there in the group. Let's see.
Well, that can remain Jabber. I suggest you just start the discussion group as.
Yeah. So Colin says it seems reasonable, but he thinks 2 weeks is a little short. But so that's saying the 2 weeks would start basically Friday. Is what I'm suggesting.
Oh, we can give more time as well, or something.
Yeah, it's not a major rush. We just need a forcing function of some sort. All right, let's see.
Go for it.
Shift to the last. Somebody had a comment?
I was just saying, go for it.
Oh, okay, probably good. All right, last item on the agenda here. We've got about 13 minutes left. Let's see, Wojtek, how can I share that tab? That opens in a separate tab.
Well, you have a share screen option in the top left, but I don't know if you can choose a tab specifically. So you open it in a new window.
Yeah, let me do that. Share screen. You really want to share your screen? Yes. All right, I only have one screen at the moment, so we'll share the one screen I have. And let's see. You should be seeing my screen there, hopefully. All right, so folks, let's see, when I'm in this mode, I can't see you all. So Wojtek, you'll have to drive and keep me on track with time and whether or not there are any questions or anything. Let's see. So I posted on the mailing list, a week or 10 days ago, a pointer to this recently published roadmap, development of quantum interconnects, QUICs for next generation information technology. This is a roadmap that came out of a 2019 NSF workshop in the United States. So that list of that long list of authors there is entirely U.S.-based authors, and so of course they all have come from a particular collective point of view. But it's also the case that the vast majority of them are physicists. And so when I read this document, I think it does a really outstanding job at covering what the state of the components is. But even though structurally within the document, there's a section that talks about modular interconnects, meaning how you can do essentially node-to-node communications for a system area network to scale up processors, and there's a section that's called quantum internet. There's really what I think of, for QIRG purposes, I think there's actually very little on what we would think of as networking for people in this community. There is a really valuable set of tables of milestones in technology. That's the set of appendices. So if you are particularly interested, I really encourage you to take a look at the document, in particular to go through the appendices. But I don't want to, I'm not going to read you the document or anything. What I wanted to do was to introduce the document very briefly, and then give people a chance to ask questions on it, or to even to think out loud about how this can potentially influence what we're doing inside of QIRG. So comments, questions, complaints, criticisms.
Hi, this is Yu Tang speaking from Huawei. It is my first time to attend the QIRG discussion, and thank you very much for referencing the paper. I have a very high-level question on this paper.
Mm-hmm.
So the milestones highlighted in this from the American scholars, and do you think this is pretty in line with the European vision? My feeling is that I thought that European advances in quantum communication is already a bit far, a bit further than the milestones highlighted in the paper. What do you think?
That's a good question. Certainly, some of the very most advanced actual experimental work is taking place in Europe, in Vienna and Delft and other places. I have not seen a detailed roadmap for come out of any of the EU or even national projects in Europe that says these are the goals we're planning on hitting, other than Delft saying that they are planning to hit actual entanglement swapping and a metropolitan area network that meets sort of the dead minimum requirements for repeaters. I think the original target for that was 2020, but we all know what happened to 2020. So I have not seen a larger, longer, more detailed or bigger vision roadmap come out of Europe. Wojtek, have you seen anything like that? Do you have any comments on that?
Not really. So there's different plans and roadmaps. There's some that are QKD specific. There's some that are non-QKD specific. For quantum repeater specific ones, then no. For QKD, one might actually jump around a bit.
So the appendix B that's on my screen here right now, timeline and milestones for modular processors, and then appendix C, timeline and milestones for quantum internet. I have not seen an equivalent for this come out of the EU, but I think that I don't think the goal was necessarily to say, this is what the U.S. will achieve, but more a matter of this is what we think is reasonable for the global community to achieve. But of course, it happens that the authors are all from an American point of view. But for example, this particular point right here on suggesting that in 3 years it might be possible to create photonic entanglement at 10 to the 8 per second. That would be an astonishing number, and so that has to be taken in particular context. I would assume that that's actually talking about generating entangled photon pairs, for example. That's certainly not creating a complete quantum internet in any way, shape, or form. So I'm not sure if that's a full answer to your question or not.
Well, to be frank, I'm not either from my side, but if I look at also these the section B that you just presented on the screen, and if I look at the number of repeater nodes, the section B, so the milestone for quantum internet.
Oh, the appendix C. Here we go.
Yeah, appendix C. Yeah. Right. Yeah, right. Appendix C. I'm sorry. So here, if I see the number of repeater nodes that to be expected in 3 years, here I see 3 memory nodes, bigger than 10 user nodes. So at least from the Delft statement that I understand, at least within 2020, 3 nodes would already be connected in 3 Dutch cities. So that makes me speculate a little bit if Europe is leading on the quantum communication networking. But perhaps it's not so important as you just mentioned. I mean, this is a community; it's a global community. It might be the vision, but the actual technology advances might be already quite different than what people expect.
I don't remember how or even if they actually define user nodes there, but those may be what in other contexts have been called measurement nodes, end nodes for that, or I'm not sure. That may be clients that are actually accessing those services. I'm not actually certain in this particular case. That's actually worth checking. That's a good point. I don't know off the top of my head the exact answer to what their definition is here. Other questions or comments? Wojtek, we're at 26 after here.
Yes, so we need to wrap up, but there's one more question from Curity, I see.
Okay.
Is like a media converter for qubits.
About this roadmap or about something else?
Yeah. About Quick as described in this roadmap, not the Google protocol.
Okay.
So the question is Quick like a media converter for qubits?
Is Quick like a media converter for qubits? In this context, so they titled this quantum interconnects, but they really mean any sort of internode communication mechanism here. So including both what I would call a system area network, or other people would call like a supercomputing interconnect or something, the interconnect for a scalable large number of nodes, and also wide area networks. So they're covering both in this roadmap. But don't be misled by the term interconnects here. They're really referring to a broad range of networks, although they don't really have sort of a lot of expertise. They don't in networks. They don't talk about system area networks versus local area networks and metropolitan area networks and transcontinental networks and transoceanic networks. That's not covered in here. There will be other roadmaps coming out. I'm certain. I have heard of multiple road mapping efforts that are actually in place right now, that are actually going on right now.
Security, yeah.
Sorry, I don't know if someone is talking. the idea of converting, a quantum bit that is represented as a spin of an electron to maybe a photon somewhere else, or maybe, I don't know, those different types is what I meant by the media conversion. Is that an important notion in QUIC, in the quantum interconnect, that you can go
Sorry,
from...
different types. Sorry, I missed that part. Different types meaning?
So you have a qubit here that's represented as a spin of an electron. You have a qubit there, or you need to turn that into a qubit that's the phase of a photon, and so there's that kind of media exchange or media interconnect, media conversion.
Yeah.
That's
So
what I meant.
entanglement of photons with stationary qubits, stationary memory qubits, is definitely one of the key pieces of technology that has to be done in part of this, and that's been understood since the relatively early days of what are called the DiVincenzo criteria by David DiVincenzo, who was a researcher at IBM and is now a professor in Europe somewhere.
Yes,
Okay.
I'm afraid we're going to have to wrap up now. We're less than 1 minute left. So any discussions, please continue on the mailing list, including the draft wrap-ups also on the mailing list. So I think that's all from me. Rodney, do you want to add anything before we shut down?
Nope, that's it. Thank everybody. Thank you all for being here. There are many other fun things going on, so we'll see you all on the mailing list, and barring any major objections, come Friday, Wojtek and I will start a 2-week last call for the architecture draft, and the use case one will be probably not very far behind that.
Yeah, and thanks Darren and Sean and Robin for help during the meeting.
Yep.
Okay, thanks everybody. Bye.